All right, so here is the algebra review. Okay, so for the first problem, it says evaluate AD minus BC for the given values of variables without a calculator. Okay, so it has AD minus BC, so let's go ahead and do that right here. AD minus BC. So we're going to substitute. A is 1/2, D is 2, minus B, which is -1, times -2/3, which is C. Okay, half of 2 is 1, minus, we know a negative is positive, so that doesn't change the sign, and then 1 times 2/3 is 2/3. And 1 minus 2/3, most people will know that that's going to be 1/3, but if you want to know how to do it mathematically, we know that 1 is equivalent to 3 divided by 3, right? Because 3 divided by 3 is 1, minus 2/3, so you see we have a common denominator, so that 3 remains, and 3 minus 2 is 1. So that's the math behind getting the answer of 1/3. All right, for these right here, we're going to evaluate each one of them at 3 points, at x equals -2, x equals 0, and x is equal to 2. All right, so for the first one, let's do this first one at x equals to -2. So we have negative, parentheses 3, close parentheses, 0.5, and we're going to change this x to -2. So half of -2 is -1. We cannot have negative exponents, so we move this to the bottom with its base, so 1 over -3. And I dropped the parentheses because negative times 3 is -3. And the exponent was -1, but when you move it to the bottom, it becomes +1, so -3 to the first power is just -3. Well, really, 3 to the first power. Okay, let's take a look at the next one. This time we're going to do x is equal to 0. So -3, 0.5 times 0. So we get -3, 0.5 times 0 is 0. Now 3 to the 0 power is 1, but we still have this negative sign, so it's going to be -1 as your answer. And for x is equal to -2, or sorry, x is equal to +2, we're going to do negative, parentheses 3, 0.5 times 2. So 0.5 times 2 is 1, and 3 to the first power is 3, and you get -3 when you multiply that negative. On to the next one. So now here we have 3 halves to the x power. So we're going to start this one at x equals -2. So we have 3 halves to the -2 power. So we talked about this one in class, where you have a power of 1 here and a power of 1 there. We just distribute it. -2 times 1 is -2, so we have 3 to the -2 power. -2 times 1 is going to be 2 to the -2 power. And also we talked about how we can't have negative exponents. So when we have this negative exponent, to make the exponent positive, we bring it to the bottom. So now we know it's going to be 3 squared on the bottom. And this one, to make it positive, we move -2 with its base of 2 to the top, and that gives you 2 squared. And now we no longer have negative exponents, so 2 squared is 4, and 3 squared is 9. So 4/9 is your answer for that first one. For the second one, we have 3 halves again, and we're going to do it to x is equal to 0. So 3 halves raised to the 0 power, and hopefully you know by now anything raised to the 0 power is 1. And there's nothing in front to multiply it, so it's just going to be that 1. Then we have x is equal to 2. So same as the first one, or very similar to the first one. So power of 1, 2 times 1 is 2, so that's going to be 3 squared. 2 times 1 is 2, so that's going to be 2 squared. And this one, we don't have to worry about negative exponents. 3 squared is 9, 2 squared is 4, so 9/4 is my answer. All right, now we're down to the last one over here. Again, we're going to do x is -2 first. So -5, no, this time no parentheses. X is now -2 minus 1. -5, -2 minus 1 is -3. Again, we have a negative exponent, so we're going to bring it down to the bottom. 1 over -5 cubed, which now becomes positive. And then we come up with the answer 1 over -125, or you can put the negative at the top. That is your choice. All right, now we're going to do it when it's 0. So now we have Negative 5 raised to the 0 minus 1 when we plug in 0 for x. Negative 5 raised to negative 1. Negative exponents, we bring it to the bottom. 1 over negative 5 or negative 1/5, your choice. And last we have negative 5, x equals to 2. So negative 5 raised to the 2 minus 1, which is negative 5 to the first, and since there is no change in sign, it's just going to be negative 5. All right, on to number 5 through 7. It says find each sum, difference, or product. So pretty much we're just simplifying. And I can see this one's off a little bit, so I will fix that in a moment. All right, so let's ignore this here. So we have negative 3x cubed plus 2x minus 1 minus 4x cubed plus 5x squared minus 9. So this, we don't need the parentheses because there's a minus sign, but we're going to drop these. So we have, let's put negative 3x cubed plus 2x plus 1. Now here we're going to distribute this. Negative 4x cubed, when you distribute it, negative times a positive is negative 5x squared, and a negative times a negative is going to be positive 9. Okay, from here we're going to combine our like terms. Remember, same base, same exponent. So we have negative 3x cubed minus 4x cubed, which is negative 7x cubed. We have an x squared right here, so minus 5x squared. We have a x, which is positive 2x, and then positive 1 plus 9 is 10. There you go. All right, for number 6, this one is one we FOIL. There's no plus or minus in between, so we know we're just multiplying. So first one, I'm going to doubly distribute 2x times 5x, so 2 times 5 is 10, and then x times x is x squared. Now we're going to distribute to the second term. 2x times negative 2 is negative 4x. We're going to take 1 and distribute it to 5x. 1 times 5 is 5x. And then last, we're going to distribute the 1 now to the negative 2, which is negative 2. The only two like terms I have are negative 4x and 5x. So 10x squared plus x minus 2. All right, we're down to our last problem here for this set. So we have a plus sign here. So it's unnecessary to have these parentheses, so I'm just going to drop them. 3x to the 4th minus 3x cubed minus 7 plus we have minus x to the 4th plus this part over here, 2x cubed minus 9. Okay, so now I just look to combine my like terms. 3x to the 4th minus x to the 4th is 2x to the 4th. Negative 3x cubed plus 2x cubed is negative x to the 3rd. Negative 7 minus 9 is negative 16, and this is your simplified polynomial. All right, let's go ahead and take a look at this next set here. So for this one, solve each equation, you must show your work. Okay, so first we're going to do for number 8 is we're going to, it's really up to you. You can distribute the 4. I've seen a lot of that done. Me personally, I'm going to divide by 4 to remove that 4 from the side. So let's go ahead and divide both sides by 4. So now you get negative 2x minus 3 is equal to 12 divided by 4, which is 3. To isolate that x, we're going to start by adding the 3 over as well. And this gives us negative 2x is equal to 6. And then we divide by negative 2 to isolate the x by itself. And 6 divided by negative 2 is negative 3. All right, for the next one, first thing we're going to do is let's go ahead and distribute this 3. So 3 times 2 is 6. 3 times negative x is negative 3x. We take this negative, distribute on this side. Negative times x is negative x. Negative times 4 is minus 4. I like to bring my variables to the left. That's just my personal preference. I'm going to add x to this side. So we have 6 minus 2x is equal to negative 4. I'm going to go ahead and take the 6 to the other side by doing the opposite operation. So that's going to subtract it. Negative 2x, because these 6's do cancel, and negative 4 minus 6 is negative 10. And last, to solve for x, we isolate it by dividing by negative 2. And negative 10 divided by 2 is 5. All right, our last question here. So let's look at this one. All right, first thing I'm going to do, I'm going to start by subtracting 4 to the other side and taking it away from 10. So I have 2/3 x equals to 6. To solve this part, I'm going to multiply both sides by the reciprocal. So the reciprocal of 2/3 is 3/2. halves. So here, the 3's cancel out, the 2's also cancel out, leaving me with just an x. And here, I'm going to do 6 times 3, which is 18. 18 divided by 2 is 9. All right, let's go ahead and keep moving forward. All right, for this one here, number 11, when we're solving this one, the best thing to do for this one is probably just to cross multiply. So x minus 3 times 10, and 9 times x. Now we're going to simplify the left side. We're going to distribute the 10. 10 times x is 10x. 10 times negative 3 is negative 30. We're going to go ahead and I'm going to subtract the 10x to the other side. The reason I do that is because I know some people bring the 9x over and move the 30. I just want to do it in as few steps as possible. So the 10x's do cancel out to 0. I have negative 30 is equal to 9 minus 10x is negative x. Then you can divide both sides by the negative 1. And negative 30 divided by negative 1 is going to be positive 30. All right, for the next one, first thing we're going to do is we need to isolate this x. We do have an x on both sides, but to isolate it, if it's being divided by 2, the inverse operation would be to multiply both sides by 2. Now I want you to pay close attention to this side because I put the 2 on the outside because I'm going to distribute it to the 2x and to the negative 3, okay? So for this first one here, 2 divided by 2 cancels to a 1, so I just have x. 2 times 2x is 4x. 2 times negative 3 is negative 6. From here, we're going to go ahead and take away 4x from the x. So x minus 4x is negative 3x equals to negative 6. Divide by negative 3. X equals positive 2. Negative 6 divided by negative 3 becomes positive 2. All right, for this last one here, for number 13 here, first on each side we're going to combine like terms. So I see 4x minus x, which is 3x, plus 2. Then we have 4 plus 9 on the right side, which becomes 13. And then again, we're going to move, I like variables to the left and constants to the right. And I'm going to do this in one step. So I want to move my variable to the left. So negative 2x, I'm going to add 2x to both sides. And at the same time, I'm going to also subtract 2 to the other side because I'm moving my constants to the right. So subtract 2, subtract 2. 3x plus 2x is 5x. 2 minus 2 cancels. 13 minus 2 is 11, and negative 2x plus 2x cancels. So now I have 5x equals to 11, divide both sides by 5, and we get x is equal to 11 over 5, or you can reduce it into a decimal if you choose and get 2.2. I believe it's 2.2. All right, let's take a look at 14 and 15. So these are your systems. So for the first one, for substitution, what I first noticed is that 14, the y equals, it's already solved, so that lends itself to easily solve for substitution by taking the expression that y equals and substituting it into the second equation for the variable that is equal to. So y equals this expression, we substituted in for that one. Before I go any further, let me label this as equation 1 and equation 2, right? You always like to label them that way so you can keep track of your work. Now, really quickly, if it wasn't solved, like on 15, neither one is solved, you want to look for opposites, like there are no opposites here. Second, you want to look for coefficients of 1 or negative 1. That way, so you can just solve it over and have that isolated. It's pretty quick to do. Okay, so the second equation, 5x minus 4y. 5x minus 4, but y is negative 3x plus 5 equals negative 3. We're going to simplify the left side. We're going to distribute negative 4. Negative 4 times negative 3 is 12x. Negative 4 times 5 is negative 20 equals negative 3. I do have two like terms, 5x minus, oh, that's right, that's a plus. 5x plus 12x is 17x minus 20 equals to negative 3. We're going to go ahead and add 20 to the other side. So we get 17x is equal to 17. You can divide by 17, and x is equal to 1. Now, we talked about this in class, solving a system, and the key word is system. A system is linear system. So you have two linear equations that if you were to graphically draw them, three things can happen. They can intersect, not intersect, or one line on top of the other. In this case, since we have x equals 1, it should be understood that the lines do intersect at a point, and the point has to be a solution, ordered pair, x comma y. So now we figured out x is equal to 1. So to solve for y, we're going to take this solution and we pick either equation 1 or 2 and we substitute it in to solve. So this one's going to be y equals, I'm using the first equation, negative 3 times x is 1 plus 5. Negative 3 times 1 is negative 3. And negative 3 plus 5 is 2. So this is an ordered pair, so my answer is going to be 1 comma 2. All right, number 15. So for number 15, we're using elimination. So elimination, you have to pick a variable and you have to eliminate it by getting opposite coefficients, okay? And what opposite for coefficients means is this. So I'm looking at these y's right here, 3y and positive y. And the reason why I'm looking at these two is because, not because they're opposites, right? 3y and y are not opposites, but I can easily manipulate this positive y to be the opposite of 3y. So what I'm really looking for is 3y minus 3y so they can cancel out and equal to 0. So the way I'm going to attempt to do this is, or the way I'm actually going to do this, I'm going to take the second equation and I'm going to multiply it by negative 3. So negative 3 times negative 5x is 15x. Negative 3 times y is negative 3y. And hopefully you can see that these are opposites now. And negative 3 times 13 is negative 39. So it's so important that you make sure you distribute it to all terms in the equation. That means across both sides of the equal sign. Now we're going to take the first equation that I did not manipulate and put it underneath the one I did. Negative 3x plus 3y is equal to 3. And hopefully you can see right here when I combine my terms, 15x minus 3x is 12x. Negative 3y plus 3y does cancel to 0. And negative 39 plus 3 is negative 36. Then now my y's did cancel, so now I can easily divide by 12 on both sides and come up with x is equal to negative 3 when you divide. Now, just like the previous question, you do have to find y, right? We got x is negative 3, so it doesn't really matter which equation you pick. I'm going to try the second equation right here. So negative 5, I know I solved x to be negative 3, plus y is equal to 13. Negative 5 times negative 3 is 15. We're going to go ahead and subtract 15 to the other side. Y equals negative 2. So then we come up with our ordered pair of negative 3, comma, negative 2. All right, for this next problem right here, for 16 and 17, I explained this before, but we'll go over it again, how to graph a line. So first off, you want to make sure it's in slope-intercept form, which is y equals mx plus b. So first, let's go with the b. The b is the y-intercept. That is where you begin on the y-axis. For m, the slope, you use the formula rise over run. But let's go ahead and break down rise over run to something more that we can understand. So for rise over run, if your number in the top of the fraction is positive, your graph goes up. If the number on the top of your graph is negative, your graph goes down. And on the bottom of the fraction, that number should always be positive, so it should always move your graph to the right. All right, so let's take a look at the first example that's already solved for y. So for this, I'm going to circle it in purple because that's the color I'll graph it. Y equals 4x plus 3. So 3 is right here. That's my y-intercept, so that's where I begin on the y-axis. And 4x, I'm going to show you right here. M is equal to 4, but I need to make it a fraction, so we put it over 1. Now I put it here so you can see the connection. 4 is positive, so I go up 4 units. 1 is positive, so I go right 1 unit. So up 4, right 1. Starting from your y-intercept, up 4, right 1. Right 1. And to go backwards, I just do the opposite. So up 4, I go down 4. Instead of right 1, I go left 1. So I'm just going the opposite, so I can graph it. And there is my graph. Now, I'm not going to connect the dots until I graph the second one, and if necessary, I will, but if I can find the intersection without actually connecting the dots, that's what I'll do. So the second one, we start with negative 2 as my y-intercept. My slope is negative 1. And to make that a fraction, we put it over positive 1. So here it's -1, so we go down 1, and this is +1, so we go right 1. So from the y-intercept, we go down 1, right 1, and we just keep going that pattern until we get towards the end of the page. And then we go backwards. Instead of down 1, right 1, we go up 1, left 1, and then boom, right there, we actually have our solution already. And we can see the solution is -1, -1. So that's the ordered pair. All right, for number 17. Before you can actually do anything, you have to solve these. So let's go ahead and take 4x plus y is equal to 2. We're going to go ahead and subtract the 4x, so y equals -4x plus 2. So my y-intercept is 2. My slope is m is equal to -4, so we're going to put it over 1 to make a fraction, so it's negative, so we're going to go down 4, positive, right 1. So down 4, right 1, right 1, down 4, right 1. To go backwards, we go up 4, left 1. All right, now we're going to graph that second line. So here I'm going to go ahead and subtract x. That's a -y. And I'm going to divide everything by -1. So y equals x minus 3. My y-intercept is at -3. My slope is 1, and my run is going to be +1. So positive, up 1, positive, right 1. So up 1, right 1. And then again, right here, we get straight to the solution, 1, 2. So I'm actually going to do this in blue ink, 1, 2. All right, let's get to these linear functions, linear inequalities. Okay, so for these here, just like the other ones, you do have to solve for y, and then you're going to graph it. And there's a few rules you have to know how to shade. So I'm going to go and write these rules real quick on how to shade this. So here are the rules. I'm going to draw a little box for you. And there's only really, after you solve it, there's only a couple things you know. First off, when looking at the, whether the graph is solid or the line is solid or dashed, and do you shade above or below the line? So if you think about it, above would be greater than. So greater than represents above. Okay? So therefore, below is representative as less than. Now, how do I know if the line is solid or dashed? Well, in order to be a solid line, there has to be an equal bar under the inequality. And no equal bar means dashed. Okay, so I'm going to use this little box to help me graph these, or not to help me graph them necessarily, but to help me graph them correctly, the inequality. Okay, so for the first one, I'm going to do this in purple. So I'm going to take 3x plus 2y is greater than or equal to -2. So when I solve this, first I'm going to isolate the y by subtracting 3x. So we have 2y is greater than or equal to -3x minus 2. Now if you want to put the 3x after, that's your choice. We're going to divide everything by 2. Now this inequality symbol, if you ever divide by a negative number, it has to flip around. But I'm not dividing by a negative, so I leave it alone. So y greater than or equal to -3 divided by 2 is -3/2. And -2 divided by 2 is -1. So just like before, we're going to graph this. So our y-intercept is -1. And our graph is -3. So -3 goes down 3 over +2, so right 2. So down 3, right 2. And backwards we go up 3, left 2. All right. Now, this is an equal bar. So if I go over here, equal bar means solid line. Next thing, this says greater than, you shade above. All right, let's go and do the next line. So the next line is going to be x plus 2y is less than 2. So again, we're going to solve for y, so let's go ahead and subtract x from both sides. 2y is less than negative x plus 2. Divide by 2. Again, if we were to divide it by a negative number, we flip the sign. This time we did not, so we don't worry about it. Okay. So my y-intercept is going to start at 1. And my slope tells me to go negative is down 1, positive 2 is right 2. So down 1, right 2. And then up 1, left 2. Now we see those two dots intersect, but that's not really what we're looking for here. We are looking for the shaded region. So that is, first off, it's less than. So there's that less than sign, so the line is dashed. And is less than, so you shade below. So below. Now, this is a system of inequalities, so we're only going to shade below where the two shadings intersect. So our shaded region is going to be this little portion right here, that little region, and that all the numbers that lie inside of this region are going to be solutions. Now, let's talk about solutions from the line. If the line is solid, they are solutions. So all these on this purple line up to this point are solutions. The points on the dashed lines are not solutions. Now, where the two graphs intersect, if those lines are both solid, it would be a solution. If one of the lines is dashed, automatically it's not a solution, because in order to be a solution of a system of inequalities, it has to satisfy all equations. In this case, it has to satisfy the solid line and the dashed line. It does not satisfy the dashed line because the dashed line is not included. All right, let's keep going. All right, for number 19, I'm going to set it up. Solving, I'm just going to work it through, so please pay attention. So Kristen spent $129 on shirts. Fancy shirts cost $19.25. Plain shirts cost $4.50. If she bought a total of 9 shirts, how many of each type did she buy? Show setup and work used to get answers. So first thing we're going to do is we're going to identify our variables, so x and y. Then we're going to define them, right? So how many of each type did she buy? So number of fancy shirts purchased, and y is going to be the number of plain shirts purchased. Okay, so the first equation I see, it says Kristen spent $129 on shirts. Fancy shirts cost $19.25. The plain shirts cost $4.50. So notice that all talks about money. So we know the cost of a fancy shirt is $19.25. We don't know how many we bought, and that's representative of X. So that's the number of fancy shirts we bought. Plus $4.50 for the cost of a plain shirt, and that number of plain shirts is currently Y, because we don't know what that is either. And the total amount that Kristen spent is $129. For the second equation, it says she bought a total of 9 shirts. So if she bought 9 shirts, she bought so many fancy shirts plus so many plain shirts, and she bought 9 total. Now the only thing I will do is show you that I solved this one for y. So all I did was subtract the x, and I got y is equal to 9 minus x. And these were the two equations I used. I went ahead and substituted 9 minus x into the equation, into the first equation. So notice I substituted for y, this for y. And then from here, I just kind of worked it through. I did have to use a calculator for one part because I can't divide that decimal. It'll take me a little bit longer than I'd like. We can combine here 19.25 minus 4.5x, which is going to be 14.75. All right, let's go ahead and subtract 40.5 from the other side. So we have 14.75x equals 88.5. Divide both sides by 14.75. And you come up with x equals to 6 fancy shirts. And if you plug into y equals 9 minus 6, which is 3 plain shirts. And I simplified it that with PS and FS just because I'm running out of space. All right, for number 20, 21, and 22, it says simplifying monomials using laws of exponents. Fully simplify the following, resolve all all negatives. So let me go ahead and show you how to do this. First off, the coefficients, you're just going to reduce them. Like 2 divided by 6, you actually just divide, which becomes 1/3. When you are dividing bases, you subtract the exponents if they have a like base. So x cubed, this is x to the first, so 3 minus 1 is 2. Over here we have y squared over y to the 8th, so 2 minus 8 is negative 6. Now here we can't have negative exponents, that's why it says to resolve all negatives. So we have 1x squared at the top, or just x squared. The 3 is positive as an exponent, so we leave it alone. But this negative 6 with its base of y, we bring it to the bottom, and it becomes positive y to the 6th, and that's my answer. All right, for this next one here, I'm going to go ahead and distribute this negative across the exponent. So we have an exponent of 1, exponent of 1, exponent of negative 3. So negative 2 times 1 is negative 2. 1 times negative 2 is negative 2, so x to the negative 2. And negative 2 times negative 3 is positive 6. So I notice this has a negative exponent, and so does this. So I'm going to draw a fraction bar. Sorry. So on my fraction bar, at the top, I have y to the 6, which is positive there on the exponent. When I move this to the bottom, it becomes negative 2 squared. Notice the negative 2 becomes positive 2. And x to negative 2, when I move it to the bottom, becomes x squared. And last but not least, we know that negative 2 squared, negative 2 times negative 2 is positive 4, x squared. All right, and for this last one here, so they're being multiplied, so coefficients we multiplied. 3 times negative 2 is negative 6. Negative 6 times 4 is negative 24. And when we are multiplying like bases, we add the exponents. So x cubed times x to the first times x to the fifth, we add it. 3 plus 1 is 4. 4 plus 5 is 9. All right, so simplify the expression. The square root of 16, that's pretty straightforward. That's just going to be 4. For 24, you can use a factor tree. I do this method where I use the greatest prime factor to simplify it. So let's start with 75. The largest prime factor, which is a number divisible by 1 in itself, that goes into 75 is going to be 5, and that goes in 15 times. The largest prime factor goes into 15 is 5, which goes 3 times. The largest prime factor that goes into 3 is 3, which goes in once. So it's a square root, and we're looking for pairs. Square root, you look for pairs. If you find a pair, you circle it, and then that pair comes on the outside of the radical. Now, we're not worried about these numbers on the inside. We're just worried about the numbers on the outside of there. So I don't have any other pairs, so numbers that I did not circle are 3 and 1. We multiply those together, 3 times 1 is 3, and we put it back inside the radical. So my answer becomes 5 square root of 3, or 5 radical 3. For number 25, 9x to the 4th. Well, these are actually both perfect squares. So the first one's pretty easy. The square root of 9 is just 3. And then we have square root of x to the 4th. Now, hopefully you understand that, you could simply divide this out using the same method, or you can understand that x to the 4th is x times x times x, and I have 2 pairs. So outside the radical, we have one pair of x's, and then we have another pair of x's. Now, notice, there's nothing left, so nothing goes into the radical, we don't need it. So now we're just going to take 3 times x, and we get 3x squared. All right, and for the last problem, we take 24 and we break it just down like 75. So upside down. Now, really quickly, you might be asking yourself, when do I know when to stop? When the bottom number is a 1, that's when you stop. So the largest prime factor that goes into 24 is going to be 3, and that goes 8 times. The largest prime factor goes into 8 is 2, 4 times, and then 2 goes into 4 twice, and 2 goes into itself once. So I do see one pair of 2's. Okay, and that's the only pair I see that goes on the outside. What I did not circle is 3 times 2 times 1, which is 6. So my answer should be 2 square root of 6, or 2 radical 6. All right, this next one, it says to factor the following by finding the GCF, the greatest common factor. So the first thing we're going to do is look at our coefficients. I see 2, 16, and negative 6. Those are all divisible by 2. And then we have x cubed, x squared, and x. They all have the same variable x. We take the common factor to be the one that has the smallest exponent. So in this case, x cubed, x squared, x has the smallest exponent, so that's what we take that has common, so 2x. So notice 2x goes into 2x cubed, 2x goes into 16x squared, and 2x goes into negative 6x. All right, from here we have 25x squared minus 5x minus 5. Here I see 25, negative 5, and negative 5 all have 5 in common. Now this time I don't put an x because this has an x, this has an x, this right here, that does not have an x. So my GCF is just going to be 5. All right, we're on to number 29. So again, same process. We see the 3 and the 3. That's what's in common. They both have x, but the smaller one is going to be this one right here, so that's just x. So 3x is my greatest common factor. Okay, now for number 30 through 33, I'm going to go ahead and do the x method. So I'm going to draw it up here how I do it. So you have this right here, ax squared plus bx plus c. That's standard form of a quadratic function. So here we put b at the top. So this is right here, the middle term goes at the top. I always divide by a because that's the the leading coefficient if there is one. And then on the bottom I do a times c. All right, so we have to think of two numbers that add to b and multiply to a times c. So these are going to be our factors, the numbers that add to b but multiply to a times c. And if necessary, we always divide by a. All right, so let me show you how this looks in the first one. So for the first one, feel free to identify a, b, and c. So here a is, so standard form, x squared 5x negative 14. So a is 1, that's in front of x squared, b is 5, and c is negative 14. So right here, b goes to the top, my b is 5. Divide by a is 1. And then a times c, so 1 times negative 14 is negative 14. So we need two numbers that add to 5 and multiply to negative 14. In this case, that's going to be 7 minus 2. 7 minus 2 is 5. 7 times negative 2 is negative 14. Now here, 7 divided by 1 is 7. Negative 2 divided by 1 is negative 2. So that's a positive 7. So when we write it in factor form, x plus 7. Negative 2 is going to be x minus 2. All right, let's go and take a look at the next one. Again, we can identify a, b, and c. So a is 1, b is 10, and c is 25. And I noticed it was in standard form. So b is 10, a is 1, and then a times c is 25. So my two numbers that add to 10 but multiply to 25 are 5 plus 5 and 5 times 5. Okay. So here, 5 divided by 1 is 5, and 5 divided by 1 is 5. So if you wanted to, this is a positive 5, you could do x plus 5 times x plus 5, or you could write it as x plus 5 squared since there are two of them. That is really your preference. All right, on to the next one. Again, it's in standard form, so let's go and identify a, b, and c. So b goes to the top, which is 10. Divide by a. This time a is not 1, a is 3. And then we take a times c. So 3 times 8 is 24. So two numbers that add to 10 but multiply to 24 are going to be 6 and 4. Now this time, just like before, I'm going to reduce. 5 divided by 1 was 5. Here, 6 divided by 3 is 2. Over here, 4 divided by 3, I can't actually reduce it to a whole number, and I cannot simplify it, so 4 over 3 is going to remain. So this is a positive 2. That becomes x plus 2. Over here, we take this number 3 on the bottom of a fraction, because we don't write fractions like x plus 4/3. We take the denominator, the bottom of the fraction, and we swing it in front of the x. So instead of doing x plus 4/3, we take that 3 on the bottom and we swing it in front of our x, and we get 3x plus 4. All right, last one, 4x squared minus 9. Again, I can do the x method. Notice there's an a is 4, There is no b, right? There's bx, there's none, so that's 0, and c is negative 9. So b is 0, a is 4, and 4 times negative 9 is negative 36. So my factors that add to 0 but multiply to negative 36 are 6 minus 6. 6 divided by 4 reduces to 3 halves. Negative 6 divided by 4 reduces to negative 3 halves. So for the first one, like I said, we're going to write x plus 3, and we take that 2 and we swing it in front of the x. So 2x plus 3. Here, notice you always, if you have a negative sign, always put it at the top. So we swing the 2 in front of the x, and we get 2x minus 3. All right, for 34 through 36, it says to find the domain and range. So the domain, if you recall, are the x values of a list of numbers. So in this case are 2, 1, and negative 4. We do want to put that in ascending order from least to greatest. So negative 4, 1, and 2. And we put braces around it because it is a list of numbers. It's a set. For my range, it's going to be the y values, 5, 0, and 9. So my first number is going to be 0, then 5, and then 9. And that's my domain and range from a list of numbers. Now for 35, we're going to look at an interval. So notice this is an open circle. So I'm going to draw an open circle right here. I'm going to trace the line. It's continuous all the way to this point at the very end. It stops, and that's a closed circle. And it's all one piece. It's continuous, so it's connected. And we're going to go from least to greatest. The least number is negative 3. The greatest number is 1. Now notice I put an open circle and a closed circle. So for my domain, it's going to be negative 3 is less than x, which is less than or equal to 1. And the reason why is because negative 3 has an open circle, so negative 3 is less than x, and 1 has a closed circle, so x is less than or equal to 1. For my range, I'm going to pretty much do the exact same thing. I'm going to start from the bottom. The bottom of this graph have 2 points. They're both closed, so it's going to be right here. And the top has an open circle and a closed circle. Closed circle will always win. So this is from negative 4 to 0. So we start from least to greatest. So we're pretty much writing it in the same, almost the same format as the domain, except the range is the letter y. So we start at negative 4. This is a closed circle, less than or equal to y. This also is a closed circle, less than or equal to 0. All right, for the next one, domain. So we have an arrowhead going here into negative infinity, and this arrowhead going here going towards positive infinity. So this one's going to be all real numbers for the domain. And for the range, bottom, closed circle right here, to the top, which is 2 arrowheads. So this value right here looks like it's negative 1. So with this one we can write, if we start from least to greatest, negative 1 is less than or equal to y, because it's the lowest point and y would be considered the highest. If you don't like to write like that, you can also write y is greater than or equal to negative 1. Your choice on that one. All right, and we're down to these ones here. So pretty much we're evaluating, we're just substituting in. If you recall, remember f of x, so this is x right here. Notice in this first one, 2 takes the place of x. And I'm also looking at the f function. So this is the f function right here, and because the reason why, I see that f right there, okay? So we're going to write it 3 times x, which is 2, minus 4. 3 times 2 is 6, minus 4, which is 2. For 38, we can see we have a g right here. And this is my g function right here. So the absolute value of x is going to change to negative 4 plus 3. The absolute value of negative 4 is positive 4 plus 3. And 4 plus 3 is 7. And now for this last one here, you're just doing pretty much like a double substitution. So f of negative 1, so 3 times negative 1 minus 4, plus g of negative 1, so g is absolute value of negative 1 plus 3. And then from here, 3 times negative 1 is negative 3 minus 4. Absolute value of negative 1 is 1 plus 3. And then from here, negative 3 minus 4 is negative 7. Negative 7 plus 1 is negative 6. Negative 6 plus 3 is negative 3. All right, last but not least, we have this graph right here. This is a quadratic function. It's a parabola. So let's see if you'll remember some of the things you can list. So first off, this dashed line right here is called the axis of symmetry. The equation is a vertical line. So we know that vertical lines are x equal, just like horizontal lines are y equal. So x equals the x value here, which is, this is going 1, 2, 3, 4. So 1, 2, x equals 2. This point right here that it's pointing to right there, that is the vertex. That's either the highest or lowest point of the graph. So in this case, the ordered pair is 2, 4. And then last but not least, we have where the graph intersects the x-axis. You've got several names for that. You have roots, zeros, solutions, and an important one, x-intercepts. So ordered pair, there's 2 of them, so that's going to be 0, 0, and 1, 2, 3, 4, 0. And that concludes the review.